Hello students, in today's class we are discussing about the unit 2. Okay, so unit 2 is basically engineering IoT networks. So in this unit we are going to study the smart objects and the things in the IoT. So what is the meaning of things and means so in the IoT. So that meaning and sensors, actuators, how these will be working and all, smart objects, then the sensor networks, connecting smart objects, communication criteria, then IoT access technology. So things we are going to study in the unit 2. To these smart objects. Okay, smart objects, the things in the IoT. So in the smart object, first we are going to study the things. So what is the meaning of things in the IoT? So imagine IoT enabled connected vehicle and roadways highlighted in this unit. Okay, so we are going to study especially so regarding the so connected vehicles. Connected vehicles means the smart vehicles and the roadways. Connected roadways are it is a meaning of smart roadways. So those are those examples we are going to take. And car as an impressive ecosystem of sensors that provides an immense amount of data that can be intelligently consumed by a variety of system and services on the car itself as well as shared externally with the other vehicle. This means, so if it is a connected car, there will be several number of sensors will be connected to that car. So means, so speedometer it will be connected. So that is one sensor, and then regarding the traffic, then regarding the wind speed also, how much is the wind speed outside, that also can be sensed, and regarding the fuel tank, how much fuel is there inside. So okay, so that tires. So we can install the so several sensors to cars. And each time those sensors will be activated and it will be generating the so data, and then that can be analyzed or consumed directly in the vehicle. So whoever is doing, so he can come to know those parameters, that is, and it can be sent externally to the other vehicles. Okay, if traffic kind things and always, so so it can be shared with the other vehicles. So other vehicle owners, they will be coming to know in this particular road traffic is there, and if any problem, they will be coming to know. So and similarly, so in the connected roadways also, so connected roadways means sensors will be connected in the roadways and that will be shared with the vehicles. Okay, and if I want to go by any, so I can access that, I can know what is the traffic, any problems occur there, whether it is in the good condition, so what is the air quality in that road, everything, all the parameters we can come to know, we can access that road. That is the meaning of connected roadway. And the car filled with the sensors of all the types, examples, so already I have given the examples, that is the temperature, location, GPS, and the pressure, velocity, all these sensors will be so existing in the car, connected cars we call. So if we use the word connected, so that gives the meaning of it is a smart car. Okay, and coming to next thing. Okay, so here, so sensors, actuators, and smart objects. Okay, in these sections, so what is the meaning of sensors? What is the meaning of actuator? What is the meaning of smart object? We are going to discuss, and then so in the next part we are going to discuss about the sensor networks. So sensor networks means so which type of design, network design, then the so drivers for the adoptions and the deployment challenges of sensor networks, all these things we are going to study in the sensor networks. So sensor network means the network so which is required to so send or analyze sensor data. So which network we are going to use? Call it the sensor network. So what is the meaning of sensor and what is the meaning of actuator? Okay, so here, so we can take the example of human. So here clearly we can analyze, okay, what is the meaning of sensor and what is the meaning of actuators. Okay, so here our human, okay, so body will be having the 5 sensors. So that is the taste, then the nose, ears, eye, and the hand touch sensor. Okay, so there are 5 so sensors are existing in the human body, and what it does means, so it will be sensing that data and it will be sending it to the so human brain. That we call it as the uplink. Okay, uplink means we are sensing the data and we are sending it to the brain. Okay, means if we touch anything, so if it is a art, so from the hand or from the skin, directly that information will be going to the brain. Okay, if we taste something, that information also it will be going to the brain. So brain is a processor. Okay, brain acts as a processor, and here also, so this processor is the microcontroller chip in the IoT. And sensors, what is the work of sensor is sensing the data and sending it to the microcontroller chip. Okay, and what is the meaning of actuator means? Actuator, so always it requires the input from the microcontroller. Okay, in our human body, so hands and the legs we can call it as the so actuators. So our neck. Okay, so whatever the information from the brain, so that will tell our hands, legs are to so move in some particular direction or what it should do. Okay, all that information, so it should be sent from the brain, and then only these will be activated and it will be working. Okay, that is the process of actuator. So here also in the IoT, so what is the actuator means? It requires the input from the microcontroller. So a microcontroller sends some input to the relay, so it should get or it should turn off. Okay, so or it should turn on. Okay, those are motors. Okay, speed should be increased, speed should be decreased. That kind of so input if it comes from the microcontroller chip, and then if it is acting, those we call it as the actuators. Okay, and best examples for the actuators are relays and motors. It may be stepper motor or it may be servo motors or any motors. We can call it as the actuators. Okay, and in the above diagram, so it is shown clearly. So real world physical environment, and then that side it is a digital representation of electrical signal. Okay, here the digital representation is there, means 0 and 1 fashion, and here it is a real world physical environment, means it is just kind of an analog. And then sensor means, so always it will be sensing the real world physical parameters, and then it will be transferred to the digital representation. And then actuator means, so input is digital representation, and the physical environment or the physical in nature. Okay, so that is the output. So that is the major comparison between the so sensors and the actuators. Okay, and coming to here, so sensor, actuators, and smart object. And smart object means it is a combination of both sensors and the actuators. Okay, suppose if we are monitoring some kind of electrical appliances in the, so some sensor we are going to fix. Okay, and if the room is occupied, okay, the sensor will be sending information to the microcontroller chip, so that microcontroller chip analyzes that so nobody is occupied in the room, and then microcontroller chip generates the input and it sends it to the relay. So relay trips the circuit and the electrical appliances in the inside that room, okay, it will be disconnected. Okay, this kind of combination of sensors and the actuators, it can be more than 10 sensors and it can be more than 10 actuators in a single project. So combination of sensors, actuators, microcontroller chip, all this integration we call as the smart object. Okay, and now coming to this sensor. Here we are discussing about definition of sensor. So a sensor does exactly as its name indicates. Okay, so sensor means so it should sense the data. Okay, sensing. So that only it senses. More specifically, a sensor measures some physical quantity and converts that measurement reading into the digital representation. So means so sensors basically, so we can classify it into analog sensors, digital sensors, okay, like that. So what it does is, so physical quantity, whatever it is going to measure, it will convert that measurement of reading, that measured reading into the digital representation, because our microcontroller chip, it can so analyze the digital inputs or the digital parameters. So always whatever the sense data, it should be converted into the digital format. So that digital representation work will be happening. So and then digital representation is typically passed to another device for the transformation into useful data that can be consumed by the intelligent devices and humans. Okay, means so digital information comes in the microcontroller chip. Again, it will be converted back to the so actual representations. So whenever we observe the actual representation, we can conclude that okay, this kind of that is the meaning of this phrase. Naturally, a parallel can be drawn with the humans and use of their 5 sensors. So already this example I have discussed in this diagram. So 5 sensors are there, then the brain is there, actuator is there. So that microcontroller chip is basically a CPU. Okay, central processing unit. What same example it is given here. So human interaction with the sensors and the actuators happens in the human body. So that one, and then so depending on the so depending on the sensors, broadly it can be classified so into so these types. Okay, so that is sensors can be so classified into active and passive. So active means so it uses the so power supply for its activation. Separate power supply will be required for that. That we can call it as the active. And if the power supply is not required, so that we can call it as the passive, means external power supply, battery. Okay, so that is what here it is given. So active means it requires the external power supply, and the passive means it doesn't require the external power supply. Okay, on this basis, so which all sensors uses the external power supply, those comes under the active. Doesn't require the external power supply, those comes under the passive. Okay, and invasive and non-invasive sensors can be categorized based on whether the sensor is a part of environment in the measurement, so are the external to it. Okay, so if the sensor is a part of environment only, okay, then we can call it as the invasive, and if it is not a part of the environment, then we can call it the non-invasive type. Example, okay, so in real time, okay, some indicator plants are there, so which will be growing on the trees, and sometimes even the some kind of algae. Okay, it grows on the trees. Plants are there, are the okay, if there is no pollution, so then so those plants will be growing. So that is a part of environment, and that is a sensor that is indicating so whether the environment is polluted or not polluted. So that we can call it as the invasive. And non-invasive means all the digital sensors, whatever we are going to use, those are not the part of environment. Okay, so that is the meaning of invasive and non-invasive. And the contact or no contact type. Okay, so directly that name only indicating. So if sensor, if it comes in contact with the physical structure, then we call that as the contact type sensors. And no contact means if it uses some kind of information, means wirelessly, if it is sensing the data, that we can classify into the no contact type sensors. Then next, absolute and relative. So if it uses the absolute scale, okay, for the measurement or to sense the data, then we can call it as the active sensors. And if it uses the relative scales for the measurement of data, then we. And then next is the area of application, depending on the application where we are going to implement that. So whether it is an industrial one or whether it is a home automation or the transportation, depending on those applications also we can classify into different types. Industrial sensors, agricultural sensors, then the medical sensors, transportation sensors, okay, like that also we can classify into different types. And how sensors measures, that is also one broad classification. Means how sensors measure principle, okay, it is measuring the parameter or it is sensing the parameter. So it can be thermoelectric, means thermal energy, it will be converted into electrical energy, and by that value we can conclude exact temperature of thermoelectric this one. And then thermoelectric, best example is our thermal gun, whatever we are using during this COVID days. So that thermal gun, basically it is a thermoelectric, temperature into electrical signals. And then the electrochemical, so it is a electrical parameters conversions. Okay, are the next principle is piezo-resistive. Piezo means pressure and the resistance. Okay, are the optic type, contactless. So that is a electric, then the fluid mechanics, then photoelastic. Okay, all these are the different principles which can be used in the sensors. Okay, and then depending on this also we can classify the types of sensors. And then last is what sensor measures. Okay, which we are going to measure. Can classify. If we are measuring the temperature, then it is a temperature. If we are measuring the water level, so then it is an ultrasonic sensor, like that. So which physical parameter or which particular parameter we are measuring, depending on that also we can classify the different sensors. Okay, and here, so this is one more broad classification of sensors. So here different types are classified based on the which principle or the which application it is going to do. Okay, different means, so it is mentioned there are many other classification and taxonomy schemes for the sensor, including those based on the material, cost, design and the other factors. Okay, depending on these factors, that is material used, then the cost, then the design and the other factors also we can classify. And that table is shown in the here. So sensor type, so first one is position. So position means, so it can be either absolute position sensors, or the relative, or the displacement sensors, or the position sensors can be linear, angular, or axis. So if we are detecting the position of the any object, okay, so there we can make use of the potentiometer. So potentiometer works on the voltage principle. So if the object is moving, then the voltage will be varying, depending on that value it will be working. Then the inclinometer, so in order to give the information of and then the proximity. So proximity sensor, it is present in the mobile. So in our mobile or the smart mobile, so this proximity sensor will be so existing. So how this will be working means whenever we move the mobile, whenever the call comes, after receiving, if we move that mobile very near to the so our so then the screen will be automatically, it will be going to the sleeping mode, means screen will be turned off. So that it happens because of the proximity sensor. Okay, basically depending on the distance, it will be working. So it will be present in our smartphone. And the occupation and motion. So, so in order to measure the occupation and the motion, so especially so that is in a particular room, where occupancy is there. So, so those sensors are the motion. So vehicle speed and also our interceptor, whatever the police vehicle they use, traffic police, that interceptor is a motion sensor. Okay, or so best example is radar. So radar, what basically it does is, so it will be focused to the sky. So if any object enters in that radar area, so it senses and it gives the information. Or the electric eye. So electric eye sensors we can use in the room. So in order to, so just to identify so velocity and acceleration. So this is another type of sensor. So in this we can so find out the acceleration and the velocity of any of the objects. So this also can be used in the vehicles. So vehicle velocity or the acceleration or the for the fluid. Okay, so fluid. Okay, so there accelerometer. So accelerometer. So definitely it is there in the all the vehicles. Whatever the speedometer we are going to observe, that is a accelerometer. And then so gyroscope. Gyroscope normally it will be used for so fluids. Okay, so these two are the best example for velocity and acceleration. And then okay, so here the force, we can use the force gauge, viscometer, viscometer for the so liquid viscosity measurement, then the tactile sensor, so that is the touch sensor. So these works on the so force. Okay, so means basically force is the measurement and then these are the different types depending on the so what we are going to measure. So we can use. And then the pressure, pressure can be measured by barometer, then Bourdon gauge and the piezometer. Okay, so these three can be used to measure the sensors, means pressure. Okay, so those are the best example of pressure sensors. And then next is a flow sensors. And flow sensor means it can be anemometer. Anemometer basically it will measure the wind. Okay, so that is the wind velocity and wind directions can be measured by the anemometer. And the mass flow sensor, mass flow means if any solid material is moving, so that can be sensed. And then next meter, so water meter we are using in so in the cities as a utility. So in the utility sensors, it is a major part. So to generate the bill, how many liters we have consumed and all, so that comes under the water meter. All this can be classified into okay, and then the next is the acoustic. Acoustic means it is related to the sound. Okay, so sound sensors means microphone. Okay, microphones are used for the audio capturing, and then geophone, and then the hydrophones. Okay, hydrophones means that is inside the water to detect the sound waves, and the geophones means inside the earth to detect that seismograph and all. It comes under so this acoustic sensors. Then next is the humidity type. So humidity sensors. So humidity means hydrogen, percentage of water molecules that is in the environment. humidity, we can go for the hygrometer, humister, or the soil moisture measurement. In the soil, how much humidity is there, that can be measured by the soil moisture sensor. The hygrometer and humister also can be used. And the next is the light. So in order to measure the intensity of light, we can use the light sensors. So here infrared sensors, photo detectors, and flame detectors we can use. Flame detectors, basically it uses the infrared rays, and depending on the intensity of the flame, so it will give us the information there or not. Okay, and next is the radiation. So in order to measure the radiation, we can use the Geiger-Müller counter or the scintiller or the neutron detector. So this basically used in the nuclear power projects. So in order to measure the radiation, or even in order to measure the our mobile radiation, so we can use this sensor. And the temperature, measure the temperature, we can use the thermometer, calorimeter, then the temperature gauge. Okay, so these three can be used in order to measure the temperature. That is a thermometer, calorimeter, and the temperature gauge. And next is the chemical. So chemical sensors. So in order to detect the chemical reactions, we can use the chemical sensors. And best chemical sensors are breath analyzer. Breath analyzer means it will be detected, and then so that pulses, heart pulses can be measured by the breath analyzer. And the next is the affectometer. So affectometer also can be used to detect the different contaminated chemicals in the air. And the next is the smoke detector. Smoke detector normally it detects the carbon dioxide which is present in the smoke detector. So if we are detecting any of the bioparameters, those can be classified into biosensors. And in the biosensors, this blood glucose biosensors are there. It will be measuring the blood glucose level. So how much glucose is present. So sugar patients can be uh, so and then next is the pulse oximetry. So pulse oximetry means it will be giving us the information about the BP. Okay, so that is the blood pressure. So in order to measure the blood, use the oximetry. And then electrocardiograph. Electrocardiograph means for the ECG. So whatever we use, that we can call it as the electrocardiograph. Okay, and here one best example is given. So this is related to the biodegradable sensor developed by the NDSU. Okay, so NDSU is an agency for smart farming. Okay, so for smart farming, they have introduced this biodegradable sensors. Okay, so what it does means, here this sensor, it is basically used for the smart agriculture or smart farming. So which uses a variety of technical advances to improve the efficiency, sustainability, and profitability. Means ultimate aim is to increase the efficiency, sustainability, and profitability of traditional farming practices. And this includes the use of GPS and satellite aerial imagery for the determining the field viability. Means that field viability we can find out by the GPS and the satellite images. And robots for the high precision planting. Means robots can be used for planting, means without any damage to plants. Okay, so there we can use the robots. So that is the another part. And then next is harvesting. So robots can be used for the smart harvesting, smart irrigation, and so on. And real-time analytics and artificial intelligence to predict optimal crop yield. Okay, by the artificial intelligence we can analyze how much yield we can get from the field. So, and the weather impacts and the soil quality, everything can be measured by this. Okay, this is smart farming, the precision agriculture sensor. It was manufactured by NDSU. Okay, and here, so this is the information about the sensors used in the so this mobile phones, our smartphones. So how many sensors we are using presently in the smartphones. So and one small vehicle means it will be using more than hundreds of sensors. Roadways means hundreds plus sensors, and the mobile. So near field communication sensor will be there in the smartphones, so that will be giving us, so if any interference is there, so radio interference that can be measured by the near field communication. And then next is proximity sensor. Already we have discussed about this proximity sensor. So it detects the nearness or the position. Okay, that is a proximity sensor. And then magnetometer. So magnetometer, whenever we use the compass, it will be showing the north, south, then the east, west, those directions. No, so there, so magnetometer will be used, and then the accelerometer. So that also it will be there. So depending on the GPS location, it will be much how many distance we have covered and all. So there are so many walking, then jogging sensors, the applications are there, apps. Okay, so those are all using the acceleration or the accelerometer. Then the humidity sensor also, it will be present in the mobile. So by using that we can get the humidity level around the smartphone. Then the gyroscope will be there. Gyroscope, basically it is used whenever we turn the mobile, so that screen rotate option, whatever it is present, so it is related to that gyroscope. Gyroscope will be detecting, so in which direction that screen is to be moved. Okay, that is a gyroscope. And then next is the moisture sensor. So that is to detect the moisture. And the microphone. So whenever we start talking, so it will be captured by the microphone. So it will be recorded by the microphone. And then next is the fingerprint sensor. In nowadays, many mobiles are having the fingerprint sensors. And then digital barometric pressure sensor. Some mobile sensor. So that is digital barometric pressure sensor. We can come to know how much pressure it is falling on the mobile from this. Then the thermometer, so to detect the temperature. And then the touch screen. Touch screen also basically a sensor. So whenever you touch some of the part of the screen, depending on the matrix position, so it will be doing its functioning. And then the light sensor. Light sensor, it will give us the information about the light intensity or the lumens, how many lumens of light it is present. And then next is, so this global positioning system, GPS. So GPS will be present in all the mobiles. So in order to detect, those information can be gathered by the GPS. That is the global positioning system. Then the pedometer, camera. Okay, so these are also different sensors. Used for the capturing of the images. Okay, this is so our regular smartphones. Okay, this is the growth and prediction of number of sensors. So from the, so you can observe, so in the beginning of the 2017, so it was only 1 crore sensors were existing, and then year by year how it is increasing per year, so that is shown. So in 2022 it is nearly, so 100 times of, so that means more than 100 crore sensors are there. And by 2037 you can imagine, so how many zeros are there, 3, 9, 12, 15. Okay, so 1 into 10 power 15 number of sensors will be existing by 2032. Okay, this is the prediction. So means from this what you can come to know is, okay, so our scope is there for the so sensors and then these IoT projects or the smart projects related to that. The scope it is indicating. Okay, and next is the actuators. Actuators already we have discussed how the actuators will be working in the physical world. So actuators basically it requires the input from the microcontroller chip or from the CPU. So then corresponding to that input, it will get activated and it will be doing its work. Okay, if it is a relay, so that information should come from the CPU, whether it will get tripped or untripped. Okay, or if it is a motor, so whether motor should be on, off, or in which direction, what speed, what voltage should be applied, what current should be applied. So all those information should be come from the microcontroller. So that we call it as basically the actuators, as already we have discussed in the introduction. Go. Okay, so here same examples are given. So whatever the human example, human body example we will consider, 5 sensors and the actuators. Okay, so that only it is discussed here. Okay, again. Okay, same diagram which we have discussed that is shown here. And then here different types of actuators. Okay, so here it is classified. Then it can be classified based on the type of motion. Okay, actuators can be classified based on the type of motion. They produce example. So whether the linear motion is required, then the rotary motion is required. Linear means linear motors we can use. Then the rotary means so normal or DC or AC motors. So those can be classified into so those rotary motors. And then 1, 2, 3 axis. Okay, in which direction on the 3 axis motions. Okay, so these comes under so type of motion. Okay, those actuators. And then power. So means actuator can be classified based on the power output. Examples: high power one, low power one, or the micro power. So it depends on the size of the actuator. So if we use the micro motors, so then definitely the micro power. So then medium one means so it is a low power. Then the high power consumption depending on the capacity of those actuators. Okay, it can be classified into so there is high power, low power, the micro power actuators. Then the binary and continuous. So depending on whether it is a so a stable one or the unstable or binary means so whether it is getting changed so on the scheduled span or whether it is a continuous one. Okay, so depending on that also we can classify. So area of application where we are going to use this actuators, whether it is a industrial application, agricultural applications, or the vehicle transportation applications, or the medical applications. Depending on that also, these actuators can be classified. And energy means which type of energy it is required by the actuators. So from that also we can classify the actuators. Okay, and here type and examples are given. So so again it is another classification of same actuators. Mechanical actuators means so it is the lever, then the screw jack, then the hand crank. Those we can call it as the mechanical actuators. Then the electrical actuators means thyristors, bipolar, transistors, then the diode. So these all comes under the electrical actuators. Then the electromechanical actuators. So AC motor, DC motor, stepper motor, these we can classify into electromechanical actuators. Then the electromagnetic actuators, Electromagnetic actuators are electromagnetic and linear solenoids. So all these solenoids, so normally we can use it for the agricultural purpose, smart farming, and then even in the wherever the fuel flow kind of applications are there, there also we can use this. So this comes under the electromagnetic actuators. Then the hydraulic and pneumatic actuators. So means hydraulic pumps or the pneumatic pumps or the lifts also, it can be classified into hydraulic or pneumatic. They're all, so it can be classified into depending on principle, whether it is a hydraulic principle or the pneumatic principle one. So that is examples are hydraulic cylinder, pneumatic cylinder, piston, then the pressure control valves, air motor, these. Okay, and then the next is the smart material actuators. Then smart material actuators are basically shape memory alloy, SMA, ion exchange, fluid, then the magneto, restrictive materials, bimetallic strip, then the piezoelectric, bimorph. Okay, all these will be classified into smart material actuators. Means it is a material only, it will be in the smart nature. Okay, and then the micro and nano actuators, then the electro, static motors, micro valves, then comb drive. Okay, these all comes under the micro and smart actuators. Okay, same only it is explained here. Okay, so means in this smart agricultural, so which are all the actuators can be used, that is discussed here. Okay, so that is after measuring the soil temperature and the plant characteristics, so depending on that, so depending on the sensor values, so here it is mentioned here in the green color, so that is variety of soil temperature and plant characteristics can be detected or found by the sensor. Okay, and depending on that we can decide the control of water, pesticide, fertilizers, herbicides, then all the intelligent actions can be decided and it will be done through the actuators. Okay, means, so control of water means if more water is to be provided means we can use the, so that what is solenoid valves, and we can operate that and we can provide the more water or the less water, that decision. Then the pesticides, whenever the pesticides are required, we can provide the pesticides, and whenever the fertilizers have to be included, means have to be put, so we can put the fertilizers, herbicides are required means that also can be so provided. All these actions, okay, or etc. actions will be carried by the actuators. So smart objects are the smart work means, so it is a combination of both sensor and the actuators. That is what it is given in this so phrase. Class, I will continue this topic.